From LUSAS version 24, you can now predefine your carriageway and store it for repeated use. Your carriageway can either use automated lane divisions, where you define total width and VLO will determine the lanes, or specified lanes, where you can specify the exact location of individual lanes and any remaining areas. VLO also now handles multiple non-parallel carriageways, allowing you to model divergent lanes, as shown here. Let's now go into a demonstration of this feature. On this slab bridge, I've already defined an envelope influence and assigned it to the surfaces. Let's now define the carriageway. Carriageway definition is now based on a single reference line, rather than two parallel curb lines. This is particularly useful for curved carriageways, where it was sometimes difficult to make the curb lines truly parallel. If we go to Bridge, Vehicle Load Optimization, Carriageway Definition, we will see those two options previously talked about, the automatic lanes or the specified lanes. Let's first look at automatic lanes. The inputs are quite simple. Firstly, what reference path is to be used. In this model, we've selected a line and we can automatically make a reference path from that selected line. We can define any offset we want between the center line of the carriageway and the chosen reference line. And we can put in the carriageway width, let's say 10 meters. We can choose the vehicle direction. By default, it's both, but you can choose forwards or backwards if you wish to. We can then see the visualization of the carriageway. So we've got a solid orange line showing the curb lines, and we can see these orange arrows showing us the direction of travel. Let's delete that carriageway, and instead, let's look at the specified lane option. The benefit of specified lanes is increased speed. Instead of VLO trying every possible lane configuration to find the worst effect, it will only try the lane configuration you've specified. Less accuracy, but more speed. And perhaps with engineering judgment, you may be comfortable that the change in accuracy is negligible. We can reuse the path that we just defined, and we can give the first lane a name. Let's call it lane 1. We can choose our type, whether it's a lane, which will take full vehicle loading, uniformly distributed load, and vehicle loads as well, or a remaining area, which, depending on your design code, will either be unloaded or will just have a uniformly distributed load. We can define the transverse offset of the start of the lane, and then the transverse offset of the end of the lane relative to the reference path. We can then choose the direction. Again, specifying the direction can increase the speed of optimization, but I don't actually know of any design code which specifies that vehicle loading should follow the direction of traffic expected on the bridge. We provide the option. It's up to you whether you use it or not. I'll use it in this demo just to show the effect. We click Tab to get another line. We can add in our second lane, and we can see the offset start is automatically filled out to be the same as the offset end. Again, it's a 3 meter lane width, so from 1 meter to 4, this lane is going to go backwards. Click Tab, and then this line, I'm actually going to make a remaining area instead, because it's only 1 meter wide. And vehicle direction doesn't matter for remaining area, we'll just leave it as both. So we can now see the visualization, where we've got the solid lines showing where the extents of the carriageway are. We've got dotted lines showing the separation between the lanes. We now have arrows on individual lanes showing the direction of the lane rather than of the overall carriageway. Now this bridge actually has a divergent lane on it. We've got a separate lane that peels off from the rest of them. So I'm going to select the lines to find the center line of that and create a separate carriageway. Again, we'll go with specified lanes, creating a reference path from this new selection, and call this lane 3. It's 1.5 meters either side of that center line for 3 meters in total. And we can see there the visualization of all of the lanes on the structure. As we've already defined the influence, we can go to Bridge, Vehicle Load Optimization, and VLO Envelope Run. We're going to run it to Eurocode recommended values, and optional code settings, I'm just going to run it for characteristic and only for LM1 and LM3. I'm going to choose all influence surfaces that I've defined, And then we come to the highway. So highway is currently showing none, but we can create a new one. A highway is made up of one or more carriageways that can be loaded simultaneously. For this structure, we're going to load both of them at the same time. So put them both into a single highway, and we can then run the optimization. Let's set active for LM1, and we'll look for maximum values of MX. If we turn on the contours layer, we can then see the optimized bending moment for the loading defined. If we select a single node, we can right-click and visualize the loading that caused the moment at that node. We can see the red shaded area showing the uniformly distributed load, and we can see the wheels of the vehicles. Now, importantly, to the Eurocode, you get a heavier vehicle in lane 1 than in lane 2 than in lane 3. And you can see that LUSAS recognizes that even though we have multiple carriageways, they're all on the structure at the same time. So when we've got lane 1 with the heaviest vehicle here, even though we've got a separate carriageway over here, we're getting lane 2 and lane 3. We're not getting another lane 1. We could also look at the LM3 results, where we can see that the heavy vehicle has been placed in the divergent lane. It's also important to note when in any version we bring out updates to the codes that we're covering in VLO. So specifically in version 24, for the USA we've updated to Astro LRFD 10th edition, and for Sweden we have updated to TRV Infra 00331, as well as updating to that latest implementation of the Eurocodes in Sweden. We've also added in the option within that to create separate results for EGA and EGB loading in a single VLO run, as that was a feature requested by our clients. Those are the updates to vehicle load optimization in LUSAS version 24.